Good morning, students. Welcome to online lecture series of discrete mathematics. Now, today we will see what is this recurrence relation. If A is equal to A0, A1, A2 up to AR is a numeric function, then the recurrence relation for A is an uh, equating relating AR for any recurrence relation of the form C0 AR plus C1 AR minus 1 plus C2 AR minus 2 plus C3 AR minus 3 plus up to CK AR minus K is equal to F of R, where R is greater than or equal to K. So this is a form of a recurrence relation. This is a one kind of form of a recurrence relation. So here R and K are the non-negative integers, where the C0, C1, C2, Ck are the constant coefficients of order K. So here, what is this order? So here, suppose AR minus 2AR minus 1 is equal to 2R. So what is the order of this equation? So what is the value of K? Highest value of K is 1. So here, this is the first order linear recurrence relation. For the second, AR minus 2AR minus 3 is equal to R square. So here, what is the value, highest value of K? Here R minus 3. So 3, right? Value of K is, highest value of K is 3. So this is a third order linear recurrence relation. So again, in next, AR minus AR plus 1 minus AR plus 4 is equal to 1. So here, highest value of K is 4. So this is a fourth order linear recurrence relation. So here you have to just remember the order, and second one, so what is the form of the linear recurrence relation? That is C0 AR plus C1 AR minus 1 up to CK AR minus K is equal to F of R. The next, that is homogeneous solution. So what is this homogeneous solution? The kth order linear recurrence relation with a constant coefficient, right? The C0 AR plus C1 AR minus 1 plus up to CK AR minus K is equal to F of R. Right? So this is your kth order linear recurrence relation. So if here, if F of R is 0, right? If right hand side is equal to 0, then the equation is a homogeneous recurrence relation. Is your homogeneous recurrence relation, that is C0 AR plus C1 AR minus 1 plus CK AR minus K is equal to 0. So this is your homogeneous recurrence relation. So using this homogeneous recurrence relation, how to find out the homogeneous solution? So for that, so you have to remember two steps here. First step is you have to find out the characteristic equation. And the second one, you have to find out the roots of the characteristic equation. Roots of the characteristic equation. So how to find out this characteristic equation first? Here we see. So the characteristic equation of homogeneous kth order linear, right? Linear homogeneous recurrence relation, right? The C0 AR plus C1 AR minus 1 plus up to CK AR minus K is equal to 0, right? So here you have to write down this equation like this. What is the order here? Kth order, right? Highest value of K is K. Kth order is, this is a kth order linear, right? There is a homogeneous recurrence relation. So here you have to write down this C0. You have to consider any variable, that is alpha, whatever you have to consider. So here we consider alpha. So C0 alpha raised to k. What is the order? Highest order is k. So alpha raised to k. Next, this is the constant coefficient as it is. So C0 C0 alpha raised to k. Here this is a constant coefficient C1. So C1 alpha raised to k minus 1. Here k, the next k minus 1. Next C2 alpha raised to k minus 2 up to ck, right? Ck, so here ck, right? Alpha raised to k minus k. So k minus k is what? Is equal to 0. So only here there is a ck is equal to 0, is equal to 0. So the polynomial equation is in alpha here. So is a root is a of a degree k. It has a k roots called the characteristic roots. So using this equation, this polynomial equation in alpha. So here of a degree k. So here we have to find out the root of that characteristic equation. So next, that is the roots of here we find out the characteristic equation, right? So next we have to find out the roots of the characteristic equation. We'll see the example how to find out this characteristic equation. So AR minus 10 AR minus 1 plus 10 9 AR minus 2 equal to 0. So this is your homogeneous recurrence relation. That is f of r equal to right hand side equal to 0. So here what is the degree of highest degree is 2. Highest degree is 2. So here what is the constants? Here constant is 1. Here constant is 10. Here constant is 9. Right? So here value of k is 2. So alpha raised to k. So alpha raised to k means what? That is 2. So alpha square coefficient is 1 minus 10 alpha raised to 2 minus 1, right? So here this is your k, right? So here k minus 1 and here k minus k. So here alpha k alpha square minus 10 alpha k minus 1. So value of k is 2. So 2 minus 1 1. So here plus 9 k minus k 0. So here equation is characteristic equation is alpha square minus 10 alpha plus 9 equal to 0. Then second example, AR plus 2 minus 9 AR plus 1 minus 6 AR equal to 0. So here we have to find out the characteristic equation. So the value of highest value of k is 2. Right? This is a 2. So same alpha square. Here constant coefficient is 1. So as it is alpha square minus 9 2 alpha square 2 minus 1 is alpha raised to 1. So minus 9 alpha minus 6 2 minus 2 0. So minus 6 is equal to 0. So alpha square minus 9 alpha minus 6 equal to 0. This is your characteristic equation. The third example, alpha r plus 2 minus 4 ar is equal to 0. So here characteristic equation. Remember here highest value of k is here 2, right? But here r plus 2 is here, right? R plus is there r plus 1? No. Directly there is r, right? So r plus 2 r. So here alpha square there is a so here alpha value of highest value of k is 2. So constant coefficient is 1. So alpha square minus. So whether there is r plus 1 is present? No. Directly r. So minus 4 alpha, right? That is 2 minus 2. So that is alpha square minus 4 is equal to 0. Because here r minus 1, but r plus 1 is, there is no r plus 1. So here generally we have seen the equation. So r plus 2 minus, right, 0 a r plus 1 minus 4 a r, right. So this is the equation like this. Actually this equation is like this. So a r plus 2 alpha square minus, this is your 0, this is your constant term 0. So 0 into alpha raised to 2 minus 1. So this is 0 term. This term is 0 term. So alpha square minus 4 is equal to 0. So this is your characteristic equation. So in next lecture, we will see how to find out the characteristic root.